In this section, I'm going to explain how we cut an external profile, a radius, and use cutter compensation, G42. For this operation, we will be using one tool, a 5mm square corner router. Here is our part. It's 100mm square with a 20mm corner radius on one corner. Our datum position is in the bottom left corner. Here is our first few lines of the program. We start off designating a program number. In this case it's 0001. On the same line we give our program a name. This is inside brackets. That means the machine doesn't read it and it's purely an operator's note. We complete the line with the end of block sign, which is a semicolon. Every line in G-code finishes with this semicolon. Moving down to our next line, we designate the tool number. The T01 says tool number 1. The second 01 is the offset number, so here we have tool 1 offset 1. We complete this line with a nuller brackets comment. This is so the operator knows what tool tool 1 is at an easy glance. The G21 command puts the machine into the metric system. For imperial, we use G20. To set the spindle speed, we use an S value. In this case, we use S700. This stands for 700 revolutions per minute. Speeds and feeds may vary depending on your machine and the rigidity. Please consult your manual for proper speeds and feeds to use for your particular machine. The M3 command turns the spindle on in a clockwise direction. G42 offsets the cutter by half the diameter. In this case, it offsets it to the left. A G41 command would offset it to the right. The P2.5 command tells the machine how much to offset it by. Where we have a 5mm cutter, we need to move it 2.5mm. Sometimes this is designated by the letter X and not P. This drawing shows cutter compensation in slightly more depth. It is available to download as part of the course. Our next line is a rapid move, specified by GOO. This can also be written purely as GO. In this case, we are moving to X0, Y -10. This gives us 5mm clearance from the end of the job. We start our approach from near the datum. We now lower our Z-axis for the depth of cut. Remember, the datum is on the top of the material, so a 2mm in the minus direction would mean a 2mm cut. Here we have our first GO1 move. GO1 is our feed rate move, so we can control the speed of the cutter movement. In this particular case, we're moving 100mm up in the Y-axis at a feed rate of 100mm per minute. Again, the feed rate will change depending on many variables. For example, if you're using a carbide cutter on a 5-axis Makino milling machine, we could do this about 6 times faster, but on a home desktop router, slower is better as to not break the cutter. Here we have our first GO2 command. And GO2 is a clockwise radius movement. We don't need to specify the Y-axis in this case. It's a straight line move with a radius at the end. So from here we use GO2 X100 with a 20mm radius, which is designated with an R value. We do not need a feed rate for this, as the feed rate was already designated on the GO1 line above. Using GO1, We now travel along the y-axis to the 0 position, which lines us up with the datum. Don't forget we are using cutter compensation, so the cutter is actually 2.5 mil to the left of the job. We don't need to add GO1 again on this line, as it's already active from the line above. A simple x 0.0 will take us back to the datum position where we first started cutting. With a Z movement of -4mm, this lowers the router another 2mm into the job, ready for our next pass of the component. From here, it's the same 4 lines that we have just cut the profile, just with the cutter at 2mm deeper. So the next 4 lines is exactly the same as the previous 4 lines of movement. We then take the cutter an extra 2 mil deeper, ready for the next pass, using Z -6.0. Here we machine the profile again, using the same lines of code as above. Now we return to our start position at x 0.0, the datum position. Using a GOO command, we can rapid the cutter 20mm above the job. This gives us plenty of clearance when we're rapiding to the home position. A G28 command is an automatic travel to the machine reference point. We can also designate X0, Y0 to take it back to the tool change position and the machine home position. The MO5 command is a spindle stop command. And finally, we add an M00 command. This stops the machine, so we're ready to do a manual tool change or end of program. And that brings us to the end of this section. In this section we covered setting the tool number, setting the metric system using the G21 command, setting the spindle speed and turning it on with an M3 command, using cutter compensation with a G42 command, discussing the linear rapid travel movements using the GO command and the feed rate movements with a GO1. We also covered cutting clockwise arcs using the GO2 movement, and how to safely lift the cutter off the job and rapid back to the home position.